Hi, welcome to this class. Today I am going to explain Vogel's approximation method in transportation problems. See here, find out initial basic feasible solution for the given transportation problem by WAM method. WAM method also known as Vogel's approximation method. Here the transportation matrix is given. S1, S2, S3 are three companies or factories which are produced products. D1, D2, D3, D4 are destinations or requirement centers. So S1 is supplied 7 units, S2 is supplied 9 units, S3 is supply 18 units. Requirements for destination D1 requirement is 5 units. For destination D2 requirement is 8 units. For D3 7. For D4 14 units. We have to calculate transportation cost. Step 1. Before going to start the solution, we have to calculate or identify whether the problem is balanced transportation problem or unbalanced transportation problem. For that, we have to calculate total supply and total demand. Total supply is equal to supply 7 plus 9 plus 18. 7 plus 9 plus 18 equal 34. Total demand 5 plus 8 plus 7 plus 14. Once again, total demand is equal to 5 plus 8 plus 7 plus 14 equal 34. Here, total supply is equal to total demand. So, the given transportation problem is balanced transportation problem. Step 2. Calculate penalty values along row wise and column wise. Penalty means it is the difference between first minimum and next minimum. So here first row, S1 row, minimum cost is 10, next minimum is 19 rupees. 19 minus 10 equal to 9. In the second row, first minimum is 30, next minimum is 40. 40 minus 30 equal to 10. In third row, first minimum is 8, next minimum is 20. 20 minus 8 is equal to 12. Similarly, we have to calculate in column wise. In first column D1, first minimum is 19, next minimum is 40. 40 minus 19 is equal to 21. In a D2 column, first minimum is 8, next minimum is 30. The difference between these two values is equal to 22. In third column, first minimum is 40, next minimum is 50. 50 minus 40 is equal to 10. In fourth column, first minimum is 10, next minimum is 20. 20 minus 10 is equal to 10. So after identify all the penalties in row wise and column wise, identify maximum value among the all these values. Here 9, 10, 12, 10, 10, 22, 21. So here maximum penalty value is 22. So we have to consider D2 column. So in this column we have to again identify least cost cell. Here 8, 30 and 30. So 8 is least cost cell. To this cell demand is 8 units and supply is 10 units. So we have to supply or we have to allocate 8 units to this cell. After allocation 8 units to this cell, 8 minus 8 is 0. 18 minus 8 is equal to 10. So this column is satisfied. So that's why it is deleted for next iteration. Iteration 2, D1, D3, D4, S1, S2, S3. D2 is deleted because it is satisfied. So here also calculate penalty values along row wise and column wise. First row, first minimum is 10, next minimum is 19. 19 minus 10 is equal to 9. In the second row, first minimum is 40, next minimum is 60. 60 minus 40 equal to 20. In the third row, first minimum is 20, next minimum is 40. 40 minus 20 is equal to 20. Similarly, in column wise, first minimum is 19, next minimum is 40. 40 minus 19 equal to 21. In this D3 column, first minimum is 40, next minimum is 50. 50 minus 40 is equal to 10. In fourth column, first minimum is 10, next minimum is 20. 20 minus 10 is equal to 10. So after calculation of penalty values, we have to identify maximum penalty. After calculation of all penalty values along row wise and column wise, once again we have to identify maximum penalty value. So here 9, 20, 20, 10, 10, 21. 21 is maximum penalty value. So we have to mark this column. In this column again we have to identify least cost cell. 19, 70, 40. Here least cost cell is 19. So here demand is 5 units, supply is 7 units. So we have to allocate 5 units to this cell. So after allocation of 5 units to this cell, 5 minus 5 equal to 0. 7 minus 5 equal to 2. So this column is exhausted or satisfied. So that's why this column is deleted for next iteration. Next iteration 3. D3, D4, S1, S2, S3 because D1 is deleted. So once again we have to calculate penalty values along row wise and column wise. For first row it is 50 minus 10. 50 minus 10, 40. 60 minus 40 equal to 20. 70 minus 20 equal to 50. In D3 column, 50 minus 40 equal to 10. D4 column, 20 minus 10 is equal to 10. So among all these penalty values, we have to identify maximum penalty value. So penalty 50 is maximum. So consider S3 row. So in this row, we allocate least cost. In this row, we have to allocate to the least cost cell. So here 20 is the least cost cell. So here demand is 14 units, supply is only 10 units. So that's why we have to allocate 10 units to this cell. After allocation 10 minus 10, so this is 0. 14 minus 10, this is 4. So this row is deleted because it is satisfied or it is exhausted. So next iteration 4. Iteration 4, D3, D4, S2, supply 2, 9, demand 7, 4. So here also in S1 row penalty is 40, S2 row penalty is 20. In D3 column penalty value is 10, D4 column penalty is 50. So among all these values, 50 is maximum value. Consider least cost cell in this column. 10 is least cost cell. Here demand is 4, supply is only 2 units. So that's why we have to allocate only 2 units to this cell. So after allocation to this 2 units to this cell, 2 minus 2 equal to 0, 4 minus 2 equal to 2. So only, so this is deleted. So next only S2, D3, D4. Here demand is 7, 9, supply is 9. So that's why 7 units allocate to the cell, 2 units allocate to this cell. So after allocation, we have to go for result summary. S1, S2, S3, D1, D2, D3, D4. So S1, D1, 5 units are allocated. S1, D4, 2 units are allocated. S2, D3, 7 units are allocated. S2, D4, 2 units are allocated. S3, D2, 8 units are allocated. S3, D4, 10 units are allocated. So the cost of the transportation cost is identified or calculated by multiplying number of units with unit cost. That's why minimum transportation cost 19 multiplied with 5 units plus 10 multiplied with 2 units. Next 40 multiplied with 7 units. 60 multiplied with 2 units. 80 multiplied with 8 units. 20 multiplied with 10 units. So total is 779 rupees. So after calculation of minimum transportation cost, we have to check degeneracy test. Number of allocated cells equal to m plus n minus 1. If number of allocated cell is less than m plus n minus 1, the problem is degeneracy problem. If the number of allocated cell is equal to m plus n minus 1, there is no degeneracy in the given problem. M is equal to number of rows, 3 rows, S1, S2, S3. N equal to number of columns, 4. D1, D2, D3, D4. 6 is equal to 3 plus 4 minus 1. 6 is equal to 6. The solution is not have the solution is non-degeneracy solution.